Astronomers have long speculated that Betelgeuse's recent unusual behavior could be a sign that the star is nearing the final stages of its life. Although records and studies of Betelgeuse go back as far as the 1st century BC, the cause of its dramatic dimming remains a mystery. Betelgeuse is moving through space at an impressive speed of about 30 kilometers per second, having been ejected from its birthplace in the Orion OB1 Association, the stellar nursery that includes the stars forming Orion's belt. This rapid movement has created a massive bow shock that extends more than 4 light-years into space. Measuring the exact size and distance of red supergiants like Betelgeuse presents a serious challenge for astrophysicists. The star's diameter is difficult to calculate precisely due to various factors, including its pulsating nature, which causes its size to vary over time, and its dimming outer edges, which alter its visible glow. These factors affect how we perceive the star's brightness, especially from Earth. Complicating things further, Betelgeuse regularly expels material into space. This expelled shell influences both the emission and absorption of light, making its brightness even harder to interpret. Its visible size can vary significantly, by as much as 35%, depending on the wavelength used to observe it. In July 2009, the European Southern Observatory released images captured by its Very Large Telescope Interferometer (VLT), showing a vast plume of gas stretching up to 30 astronomical units (AU) from Betelgeuse's surface, about the distance between the Sun and Neptune. This was one of at least 6 massive outflows observed around the star. These mass ejection events are thought to hold important clues about how red supergiants shed their outer layers near the end of their life cycles, a key factor in their eventual destruction. Despite ongoing research, the dynamics of Betelgeuse's extended atmosphere remain enigmatic. The exact process by which red supergiants lose mass is still under investigation. However, advances in interferometry are bringing astronomers closer to understanding these complex mechanisms. Red supergiants like Betelgeuse play a crucial role in recycling elements throughout galaxies, making their study essential. In 2019, using data from the Hubble Space Telescope and other observatories, scientists discovered that Betelgeuse had ejected a significant portion of its outer shell. This event, known as a surface mass ejection (SME), was far more powerful than solar mass ejections from our own sun, expelling material estimated to be 400 billion times more massive than a typical solar eruption. This immense outflow likely explains Betelgeuse's sharp drop in brightness, starting in October 2019. By mid-February 2020, Betelgeuse had lost nearly 2/3 of its brightness, dropping from a magnitude of 0.5 to 1.7. On February 17, 2020, the star's brightness had stabilized for over a week, and by February 5th, the dimming seemed to have halted. Despite speculation, this drop in visible light was not associated with an imminent core collapse, as no significant changes were detected in the star's infrared output by February 24th, 2020. If you enjoyed this overview, feel free to share your thoughts in the comments. Don't forget to like the video and subscribe so you won't miss future updates on fascinating cosmic phenomena like this. When Betelgeuse eventually goes supernova, it is expected to be one of the most spectacular astronomical events ever observed. Even though it lies around 640 light-years away, the explosion will be so bright it could outshine the full moon, visible during the day for several weeks or even months. One of the most fascinating celestial events is a potential supernova of Betelgeuse, located at the prominent shoulder of the Orion constellation. Betelgeuse is a red supergiant nearing the end of its stellar life. In 2019, this once brilliant star unexpectedly began to dim significantly, noticeable even to the unaided eye. Over several months, its brightness diminished so much that astronomers and sky watchers speculated whether the star was on the verge of dying. Telescopes were turned toward Betelgeuse, and researchers were stunned by the evidence of its dramatic fading. Scientists believe Betelgeuse may be close to exploding in a supernova, marking the end of its life cycle. But when exactly will this cosmic event occur, and why? Could it have devastating consequences for Earth? Betelgeuse, the bright reddish star located on Orion the Hunter's upper right shoulder, is also known by its formal name, Alpha Orionis. While it is the second brightest star in Orion, after the blue-white supergiant Rigel, It continues to captivate astronomers due to its erratic behavior and unique characteristics. Typically, alpha stars are the brightest in their constellations, but Betelgeuse garners attention for its immense size and deep red color. Classified as the 10th brightest star in the night sky and the 7th most visible to observers across much of North America, Europe, and Canada, Betelgeuse's name comes from Arabic, meaning armpit of the giant, a reference to its position in Orion. Betelgeuse loses approximately one solar mass every 10,000 years, expelling material in all directions and forming a surrounding nebula. This nebula stretches about 30 astronomical units, AU, 30 times the distance between Earth and the Sun, and is 250 times more massive than the star itself. At its core, Betelgeuse fuses hydrogen nuclei into helium under immense gravitational pressure, releasing light and heat. As it exhausts its hydrogen, the star begins fusing helium and later carbon. Once helium is depleted, neon and carbon combine to produce iron. However, iron fusion doesn't release energy. This causes the star's core to collapse under its own gravity, ultimately leading to a supernova, one of the most powerful explosions in the universe. Stars emit light in different wavelengths depending on their age and stage of development, from the bright blue of young stars to the reddish glow of aging giants. The ancient stargazer Tycho Brahe once described Betelgeuse as having a ruddy hue. Earlier Chinese astronomers, however, noted its yellow color, suggesting it may have once been a yellow supergiant. Massive stars like Betelgeuse burn through their hydrogen fuel quickly, living only about 10 million years. Brief compared to stars like our Sun, which still has over 5 billion years to go. There's no doubt Betelgeuse is in its final evolutionary stage, making a supernova inevitable. However, the exact timing remains uncertain. Betelgeuse also undergoes two brightness cycles, one that recurs every 5 years and lasts about 100 days. These fluctuations are thought to result from the expansion and contraction of its outer layers, affecting both its diameter and surface temperature. Public interest in Betelgeuse surged during its dramatic behavior in 2019 and 2020, when its light faded unexpectedly before recovering briefly. This mysterious dimming sparked global curiosity and renewed scientific focus on this enigmatic red giant. A supernova releases more energy in just a few seconds than our Sun will emit over its entire 10 billion year lifetime. When such an explosion occurs, its light will travel through space and eventually reach Earth, appearing as an exceptionally bright point in the sky, unlike anything we've seen before. Despite how dramatic that sounds, there's no need for concern. Even though a nearby supernova may seem dangerous, Betelgeuse is far enough away that its explosion poses no threat to Earth's biosphere or any form of life. What it will offer is a rare and remarkable opportunity for scientific discovery. In recent years, Betelgeuse has returned to its usual brightness, though its unusual dimming episodes are still under close observation. Scientists are using advanced instruments such as the James Webb Space Telescope, the Hubble Space Telescope, and powerful ground-based arrays like VLT and ALMA to monitor changes in the star's brightness, surface activity, and ongoing mass ejections, signs that suggest instability. One widely supported theory suggests that Betelgeuse's dramatic fading was caused by a massive cloud of stellar dust formed during an outburst. This cloud temporarily obscured the star's light from our perspective. Studying Betelgeuse is helping astronomers understand the life cycles of massive stars, especially those nearing the supernova phase. These insights may eventually enable scientists to predict similar events in distant galaxies, understand how elements like iron and gold are created and spread through the universe, and reveal how stars contribute to the chemical enrichment of space. Betelgeuse is, in essence, a ticking cosmic time bomb. It could explode tomorrow, next year, or not for another 100,000 years. But when it does, it will be a breathtaking celestial event, offering an unparalleled wealth of scientific data for generations to come.